In this video we will see how to solve round robin. You can see the table is provided with time quantum as 2 milliseconds. Now round robin is based on a algorithm where a process is being allocated a time slot, that is the time quantum. A process can utilize complete time quantum or it can use some part of the time quantum. This will be demonstrated while doing the example.
Hit the subscribe button and hit the bell icon to never miss an video from Future Vision BIE.
Okay, the first step is to draw the Gantt chart. This takes a long Gantt chart to complete it. So let's see. Now P1 arrives at 0 milliseconds. That has a burst time of 9. Right? So according to time quantum, it can use only 2 milliseconds. So at 0 arrives the process P1. It can utilize till 2. Right? Then it is been preempted. Now 9 minus 2. Okay. Now process 2 arrives at 1 milliseconds while P1 was executing. So P2 gets into the execution from P2 to P4 according to time quantum. So which has 4, now reduced by 2. Now we have executed till 4th millisecond, so all the process arrives into the rarity queue having these values 9 and 5. So next P3 gets times quantum, so P3 gets into time quantum, can execute 2, that is 6. Okay, now 9 minus 2, that is 7. Now P4 gets the time quantum, P4 8. We have 5 minus 2, that is 3. Now again we'll come and check here P1 which has 7. P1 10. 7 minus 2 5. Next P2 has 2. P2 plus 2 10 12. So P2 gets completely executed. Next we have P3 which has 7. Now P3 time quantum is 2, therefore 14. 7 minus 2, that is 5. Now P4 comes in, it takes 16 reduced by 2, that is 1. Now again it takes P1 would occupy 2, again it is 18. P1 minus 2, that is 3. Now as P2 executed completely, we need not to consider. Next P3 takes 5. P3 20, it executes for 2 milliseconds, 3. Now P4, as I said before, time quantum is 2 and a process can utilize complete time quantum or a part of it. So P4 executes only 1 milliseconds. You can see here P4 will execute only 1 milliseconds, therefore it's 21. P4 completes its execution completely. Now it is between P1 and P3. Now P1 comes into the picture, it executes for 2 milliseconds, that is 22. As there is no space, I'll draw the continuation of the Gantt chart here. It starts from 22 milliseconds. As we know, P1 executed for 2 milliseconds. Therefore, I'll reduce it by 2. This remaining is 1. Next is P3. It's 22 plus 2 is nothing but 23. 23. 23. Okay. Now the last execution was P1. We have reduced it. Next is P3. P3 takes up to 25. P3 will now be 1. Next is P1 with just 1. P1 will execute till 1, that is 26. P1 completes its execution. Now rest is P3. P3 with 27. Our gang chart is ready. Now to check whether we have encountered an error, we can do a way is to sum of all the burst time, which is nothing but 27. Now do we have 27 here? Yes, so therefore we have encountered no error while drawing the gang chart. Now step 2.
Hit the subscribe button and hit the bell icon to never miss an video from Future Vision BIE.
In this step, many of you might go wrong. To calculate the waiting time, is nothing but service time minus already executed time minus arrival time. Okay, so let's see the step 2 here. We already have the gang chart drawn to our left side. Now here we will always find redundancy or multiple context switching happening here. P1, 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 P1. So which service time to take? The service time you should always consider the highest of all. So the highest of all is 25 for P1, right? I will consider this waiting time of P1 equals 25 minus already executed time. So here you can see there are multiple execution times, right? P1, P1, P1. So first we have to see what are all the multiple executions times here. This is first, P1 is second here, P1 is third, P1 is fourth here. Next, fifth P1. You can see on all the numbers 1, 2, 3, 4, P1 has the execution time of 2 milliseconds, whereas last P1 has the execution time of 1 millisecond. As we have already taken service time into consideration, we may not take this into consideration. So we have 4 P1's execution. Now to find between it is 2 minus 0, which is equal to 2 milliseconds. Same way for all, we'll find 8 milliseconds to be executed already. So therefore I will write here already execution time is 8 minus arrival time. Arrival time of the P1 is 0. Write it as 0 here. P2 equals the same way. Now P2, the last occurrence of P2 was here, right? We don't have P2 here. We don't have P2 in anywhere specified. The last occurrence is P2, that is 10. So I'll consider this P2 here just to be 10. The service time of P2 is 10 now minus the already executed time. Do we have occurrence of it? Yes. How many? 2 milliseconds has been executed. So we draw it 2 here minus burst time. Arrival time of P2 is 1. So arrival time of P2, I write it as 1 here. Now P3. For process P3, the last executed process service time was 26. I considered this Now 26 to be here, 26 minus already executed of P3. Now we will check. P3 was here 1, P3 2, P3 3, again 4, right? Every place P3 takes up 2 milliseconds. So there are 4 occurrences, 4 2s are 8. We'll just add here 8 here, minus arrival time of P3 is 2. Simply write 2. Next P4. P4 we have the largest is this, so I consider P4 to be this, service time to be 20. Just write it here, 20 minus already execution. Can we find here P4 number of times is 1, P4 is 2, that's it, right? So P4 we have 2 occurrences which usually takes 2 milliseconds, so therefore I write it as 2 minus arrival time is 3. Simply calculate it. Calculating it, 25 minus 8, 17, 10 minus 2 minus 1, 7, 26 minus 8 minus 2, 16, 20 minus 2 minus 3, 15. Alright, to find the average time we have to take sum of all. So taking sum of all, 17 plus 7 plus 16 plus 15, 55, just nothing but 55 by 4, right? 55 by 4 is 13.75 milliseconds. Always write it down. The average waiting time is 13.75 milliseconds.
Hit the subscribe button and hit the bell icon to never miss an video from Future Vision BIE.
Okay. Step 3, to calculate turnaround time. Turnaround time is nothing but waiting time plus burst time. In step 2 we already figured out what is the waiting time of all the processes. We simply take down the process P1, P2, P3, P4. The waiting time of P1 used to be 17, P2 used to be 7, P3 used to be 16, P3 done, P4 is 15, and P4 is 15. Now we have to take down the burst time of all the processes. Burst time of all the processes is already given in the table. That is nothing but 9495. 9495. Do note that it is always in the order of the same thing where we are taken in the table, or else you might take down the wrong values here. Now we simply calculate it. 17 plus 9, 26, 7 plus 4, 11, 16 plus 9, 25, 15 plus 5, 20. Now it is optional to figure it out the average turnaround time. I usually calculate average turnaround time. The sum of all is 26 plus 11 plus 25 plus 20 is 82. 26, 11, 25, 20 82. 82 by 4 is nothing but 20.5. Average turn around time is 20.5 milliseconds.